Hello, you're welcome back. Okay, so we are still on chain rule and we'll continue from where we stop. Okay, already I've told you that a chain rule uh, is used to find the derivative of function of a function. Okay, so now sometimes you might be given a very complex okay function to find the derivative, which um, of course might also require you applying chain rule and product rule at the same time. So sometimes if you don't know how to apply shortcuts, especially when you see a function that requires chain rule, then you end up either your solution might end up being ambiguous, or you can even make mistake in the process of solving that particular derivative. Okay, let me tell you what I mean. For example, you have been given a derivative where of y to find, you are being given a question to find the derivative of y, being equal to sine of 5x plus 2, then multiply dot exponent exponent 3x plus 2. Now this is very complex derivative. Why? Because there are two rules that you need to apply here. I have function of a function, and at the same time I have a product function. So now I can't do this conveniently without me knowing how to apply um it, work on this function of a function by a simple shortcut. Why? Because the product rule and the rule for the chain rule, I can't just do everything separately then and now bring it back. It will make my solution to be ambiguous, and at the end of the day, I might even make mistake in the process. So now I'm going to introduce um the shortcut to chain rule. All right, now let's say you have this particular chain this function of a function too. You are asked to find the derivative of this function. Simply the derivative of this function is dy dx is going to be equal to the derivative of the inner function, which of course is 5, then times the derivative of the entire function, which of course is the sine of sine 5x plus 2. That's gonna give me cos. So cos 5x plus 2. So in this case now I'm actually looking at I'm taking the 5x plus 2 to be just x. Of course, when I find the derivative of cos sine x, I will have cos x, if that actually makes sense. Now this is one example. For example, let's look at another example. Let's say I've been given exponent 2x. Now and you have to find the dy dx. The very first thing I'm going to do is I look at the linear function. Then I'll find the derivative. The derivative of 2x is 2. Then the derivative of exponent 2x is still going to be what? Exponent 2x. As simple as that. Let me give you another function. Let's say you have y equal to ln 3x minus 2. So let's do this. Dy dx is going to be equal to, first of all, go to the inner function, which is the linear function, the inner function. The derivative of 3x minus 2, that gives me 3. Then of course times the derivative of ln of the entire function. Remember ln, the derivative of ln is always 1 all over. That's going to be 1 all over 3x minus 2. Okay, so which of course is gonna give me 3 divided by 3x minus 2. So without actually applying this the long process of chain rule, okay, because of course this is chain rule, without going through splitting the function into u and of course y, then differentiating them separately, I can actually do this just in one line, okay, and it actually shortens my solution, so that way, okay, if I'm being given that the function, a complex function that, okay, that involve both function of a function and a product function, for example, what I gave earlier on, let's say I have, okay, times exponent of 3x minus 2. So if I'm being given this, it will be easier. So now I can now solve this. So solution. So apply shortcut to this. Now remember product rule, okay? In product rule, let me still give you the formula again. Divide x is gonna be equal to, you keep v constant, okay? This is u and this is v, right? You keep u constant, you differentiate v dv with respect to the x, then plus you keep the v constant, then you differentiate du, all right, du with respect to the x. So in this case now, of course, that's for product function of y being equal to u times v uv. So in this case now, my u is this sine 5x plus 2, and my v is exponent of 3x minus 2. And two of these two functions, they are all function of a function, okay? So I'm going to use this product rule to solve it. So let's start. So divide the x now is going to be equal to, so the very first thing, I'm going to keep my u constant, so I will write it, that's going to be sine 5x plus 2, then dot times, I have to differentiate, okay, my v is exponent 3x minus 2. Now remember what I told you, this is a function of a function, so I'm applying shortcut. So that's going to be, first of all, I'll do the derivative of the linear function, okay, or the inner function, and that's the derivative of 3x minus 2, and that gives me 3, then times the derivative of the entire function, which is still going to be exponent 3x minus 2. Okay, so I'm done with that. Then plus this time around, now I'm keeping this constant, exponent 3x minus 2 constant. Then I'm now gonna differentiate this sine 5x plus 2, and you know that's also a function of a function, okay? So if I differentiate 5x plus 2, of course you know very well that I'm gonna have 5, okay? So that's gonna be dot 5. Then if I differentiate the entire function sine 5x 5x plus 2, that's gonna be cos 5x plus 2. Okay, so it's as simple as that. So everything now is just as simple as that. So I can write it this way. Okay, so my entire answer now is gonna be equal to 3 sine 5x plus 2. Okay, then exponent 3x minus 2, then plus 5 cos 5x plus 2, then exponent 3x minus 2. So that is how you apply shortcut to chain rule, okay? And that's the application. So let's look at another example. Let's look at a situation where I'm being given y being equal to, okay, x plus 1 all cube times ln 2x minus 1. Okay, so to find dy dx. Okay, so now solution. Function of a function, and of course this product. So you know how we do this. Keep this constant, differentiate this, then keep this constant to differentiate this, right? So divide the x is going to be equal to, I'm keeping this constant, that's going to be equal to x plus 1 all cube. Of course, if I'm differentiating this, I have to differentiate the inner function first, right? And the inner function, that's going to be 2, and of course times the derivative of ln 2x minus 1, which of course will give me 1 all over 2x minus 1. Then plus, I'll go the other way around. This time around, I'm keeping this constant. That's going to be ln 2x minus 1, bracket open. Okay, so 2x minus 1, bracket open. Then I'm having okay, so I'm not going to differentiate this. So differentiating this, you know what I will do? The inner function here, the derivative is 1, derivative of s is 1, derivative of 1 is 0. That's going to be 1, okay, times the derivative of the entire, okay, remember the whole of this now serves as x, right? It serves as x. Then of course you know how you do, the 3 comes at the back, that 3 times 1 already, that's going to be, this is going to be 3, okay. Then of course bracket open, x plus 1. remember the formula is always given as nx n minus 1, okay. The n being 3 has come to the back. Then of course the power now have to be reduced by 1, and that's going to be 2. So that is my answer. Okay, so I can write it this way. This is going to be equal to 2 into x plus 1 all cube divided by 2x minus 1, then plus 3 bracket open x plus 1 all square, then ln of 2x minus 1. Okay, so that is the combination of chain rule and of course product rule. Okay, now we're going to go to the next technique of derivative. This time around we're going to look at the technique for quotient. Okay, so call this one quotient rule. Okay, so quotient rule. Now we basically use quotient rule, okay, to find the derivative of we use quotient rule to find the derivative of a quotient function. Of course, you know, quotient, in quotient we are dealing with division, right? For example, y is equal to u all over v. This is what I mean by quotient. Okay, and you know very well that the u is a function of x, and of course the v also is a function of x. Okay, u is a function of x, and of course v is a function of x. So this is quotient. The u here is the numerator of this fraction, and the v is the denominator. Okay. All right. So in this case now, for us to be able to find the y with respect to the x, okay, simply what we do is we keep the same procedure for product rule, but there's a slight difference. Okay, so we start by keeping the denominator v constant, then we differentiate the okay. So v du dx, then this time around is minus, not plus. Okay, now keeping u constant, I'm going to differentiate v with respect to the x. Now another difference is that after you are done with all this, okay, so you have to divide everything by v square. V, of course, is the denominator of v square. Okay, let's illustrate this. For example, if y is equal to x squared all over cos x, okay, then find the y dx. Okay, so now let's solve this. Solution. So of course, in this case now, my v will definitely be the denominator, which is cos x, and my u is the numerator, that's s squared. So applying our formula, the y dx is gonna be equal to v all over du dx, then minus du v times du dx, please, v then multiply by du dx. Okay, then of course u times dv all over the x, then divided by v square. So let's start. What's my v cos x? So what's the derivative of u? If I differentiate x squared, of course, you know what I will have? I have 2x. Then minus. What's my u? My u is s squared. So I keep my s squared, u constant, I differentiate cos x, which of course, that case means minus sin x. That gives me minus sin x. Then I divide it by cos v, be the denominator, that is cos square x, that's v square, cos square x. So this is going to be equal to, so 2x, this is going to be 2x cos x. Then of course minus times minus is plus. Okay, that is plus s square, excuse me, s square sin x, s square sin x, then divided by cos square x. Okay, so you can still break it down if you wish to. You can still break it down by okay, let's see whether it's really necessary. Okay, I can divide this. If I divide cos x by cos square x, I'm left with, because this is all, these two expressions being divided by cos square x, so I can divide them individually. So cos x divided by cos square x, cos x cancel itself 1, cancel cos square x, I have cos x, so I'm having 2x, okay, all over cos x. Okay, then of course in this case I'm having s square sin x, right? Sin x all over cos square x. Of course, cos square x is cos x times cos x. Okay, So in trigonometry, we know already that sine x all over cos x is tau x, and 1 all over cos x is giving us sec x. So this is gonna be now 2x. 1 all over cos x is sec x. Okay, this is gonna be plus s squared. Okay, so s all over cos x, that's tan x, and of course 1 over cos x, that's sec x. So we can actually break it down, okay, up to this point, or you can leave your answer, okay, depending on what the examiner requires. Okay, so I hope that is well understood. So this is quotient rule. Now remember, I told you that I wanted to prove the derivative of y being equal to tan x. Okay, then I didn't do it. Why? Because I have not actually introduced quotient rule, which of course we know that tan x is equal to sine x all over cos x. So I can actually do that now. So how can we do that? So now I'm going to apply quotient rule to prove this. Of course, you know very well that this is my v, this is my u, please pardon me, and of course this will be my v. So that means divide the x now. Okay, remember what actually the derivative of this actually gave? What we had, the derivative of the standard derivative is sec square x. So I want to prove it now. So now let's do it. Divide the x. Of course, you know what we do first. Keep cos x. That's v cos x, okay, constant. Differentiate sine x, which of course, if I differentiate sine x, I'll have cos x. Then minus. Now this time around, I'm keeping sine x constant. All right. Then I now differentiate cos x. If I differentiate cos x, okay, you know what that means. That's minus sine x, right? Minus sine x. So all divided by cos square x, the denominator v square, right? All divided by cos square x. So if I should do this, this is going to cos x times cos x, that's cos square x. Of course, minus times minus, there's minus here, okay? It's plus. And sine x times sine x, that's going to still give me sine square x. Okay, so all divided by cos square x. All right, so now let's do this. In trigonometry, if you can still remember, cos square x plus sine square x is always equal to 1. It's always equal to 1, okay? Divided by cos square x. And you know very well, 1 all over cos square x, that's the reciprocal of cos. The reciprocal of cos x is sec x, okay? So that simply means that 1 all over cos square x is going to be equal to sec square x. So that is the proof of this. So I hope you've taken note of that, okay? So we're still going to look at other rules and the application, okay? So see you in the next video. Thank you.